event discussion, there's two events I want to combine. They both come out of Berkeley. One is Michael Jordan, professor of engineering there. The other is a professor at the Haas School of Business. I want to combine them because they both touch upon something that is fascinates me, and that is the combination of markets and reinforcement learning. Michael is a little bit more general in his talk. He talks about machine learning and AI in general as a tool for microeconomic analysis. And the professor, I have all the names in the show notes, so I don't want to be boggled down with details now. So the gentleman from Berkeley, from the Haas School, he talks about reinforcement learning as a tip for humans. And I thought that was really interesting because this is the inverse of RLHF. So it is reinforcement learning with machine feedback. So you're trying to improve decision making by humans from a reinforcement learning data set. And Michael, again, Michael is more general. So I want to combine those two presentations because they both, there's a Venn diagram where they match, and that is where we can use machine learning methods to generate better outcomes in scarce environments. So, for example, Netflix can treat its film recommendation engine like a game where the agent, which is the customer, is playing a game where they either watch a Netflix movie or they don't. And if they don't, then they might actually cancel the subscription towards the end of the month. So in that sense, even very simple things like film recommendations or book recommendations could be viewed as multi-agent game theoretic processes where you could use reinforcement learning or other type of data analysis, whether it's pattern matching, whether it's plain vanilla, supervised learning, or more sophisticated Q learning in terms of reinforcement learning. It doesn't matter necessarily what model we're using. I think the concept as a whole is worth discussing, and then we can talk about the actual individual models. This is the Not Even Wrong podcast. It's March 6, 2024. This is Krim Delco. It's the second installment of today. We are down 16.9%. The market is up 6.3%. We're underperforming at 23.2%. Let's get right into it. So we have two events today. One is a lecture by Michael Jordan, which I didn't attend. I did it online. And the other is actually a lecture that was at the business school. And it was, the context was, I'm going to start the business school lecture. So this is reinforcement learning with machine feedback. So the idea is the following. Let's say you have take Uber, for example. So you have Uber, which has thousands and thousands of drivers, and we could potentially generate an offline reinforcement learning data set from those drivers and learn a certain, let's say, we can learn a distribution, a data distribution, or a certain action state tuple pair, a set of action state tuple pairs that are optimal to achieving a certain goal. So we could have, we could use the data set of drivers and potentially train a reward function that maximizes reward and allows for optimal behavior. So in that sense, you could have a scenario where we could then recommend to drivers in New York City to do maybe certain things that they wouldn't do otherwise. So the idea is really, if you think about it, what this professor is trying to do is he's saying, look, we're learning from humans, but we want to improve human action because we have so many data points from humans that as an aggregate, maybe there is some knowledge that the individuals don't have. This is the fundamental idea. And then you can have certain models, whether it's Q-learning or even transformer-based architectures. I think the actual engineering warrants a whole different conversation. I'm not very versed in the actual models and the actual implementation and the engineering, but the concept, the idea, again, is we use offline reinforcement learning from a massive data set of let's say, Uber drivers to find optimal action state tuples that then can be used to optimize the reward function that then can be applied to, let's say, individual drivers and help them get better results. Michael Jordan's idea is a little bit more subtle. Where he's going is he wants to build microeconomic tools for market-driven decision-making agents. And what Michael is implying, which is also in the Haas School presentation, there is a potential incentivization, a potential reward system implied in the models, which is, of course, what reinforcement learning is all about. We just don't call it like that. If you think about it, reinforcement learning is, in a sense, microeconomics applied to decision making. Just called reinforcement learning, but what is a reward? It's payment, right? You can pay somebody or you can punish somebody, you can make somebody pay. So in that sense, it's very similar. So I think that's why I think Michael Jordan is very close to this presentation. And I don't even know if they work together, but I think fundamentally, for me as a trained economist, this is a really interesting topic because I think that again, the concept is very simple. Okay, whenever we have a large data set, so for example, Tesla could use reinforcement learning for their GPS navigation system. I mean, potentially, right? We could have better navigation, particularly if we add battery preconditioning, weather conditions, and those sort of things to the equation. We could have more optimal path planning for Tesla, and that could be combined with reinforcement learning in a sense that we could have offline reinforcement learning from the thousands and thousands of drivers that then generate an optimal path towards, let's say, if I drive from San Francisco to Tahoe, how could I plan this trip? Maybe there are certain things that the system could recommend me, go a little bit earlier. Maybe don't pick up your kid on Friday after school. Maybe ask, for a bit of an earlier recess, because if you 1 hour earlier could save you 2 hours of driving. Those sort of things that probably are intuitively that we know about, but again, if we have a massive data set of diverse drivers that solve problems that are sort of in this space, then we could maybe find more optimal paths towards the particular problem that, let's say, a driver is confronted with. So to summarize, reinforcement learning with machine feedback, which is the presentation I attended today from the professor at the Haas School, I think really interesting. There's a lot of thinking in terms of what kind of models. I mean, this is really a reinforcement learning problem, and it goes back to modeling, algorithmic thinking, and also architecture design. So should we use transformer-based models and then use reinforcement learning for fine-tuning, for example? So the same way we have reinforcement learning with human feedback, we could have the same applied here. We could have a data set of, again, let's say, Tesla drivers. We could do masked autoencoders, create a massive data set of distributions of tokenized distributions, and then use fine-tuning through reinforcement learning, maybe with human feedback or with DPO, to optimize policies that then can be applied towards recommendations such as whether how you should drive from X to Y. Those are interesting problems. For me personally, right now, it's more of a proof of it's a conceptual idea. I think there is. I'm going to do more research in this field and potentially also see if there are applications. I mean, you could see this being applied again with the Tesla, GPS, with the auto bidder in the energy markets. Uh, I think Michael Jordan's idea, the fundamental idea that we could have more data-driven and decision-making technology, which is rooted in modern AI architectures. That, to me, is the great idea that warrants further research. Thank you.